Hi, everyone. This is Mr. Fitzpatrick going over the solutions to the 2022 Physics Regents exam. So I'm just going to go through it as if I was doing the test. I do have the answer key right next to me just to make sure I'm not getting anything wrong. And then I have my reference table on my calculator. And I do have a protractor tool up here too on the Smart Notebook. So which terms identify two scalar quantities? So I'm going to cross out anything that's a vector. So force, acceleration, impulse, and velocity are all vector quantities. So if I'm just looking for the two scalars, that's got to be choice 4, energy and time. Question 2, motorcyclist initially traveling at 15 meters per second accelerates uniformly at a rate of 3 meters per second squared to the east to a velocity of 21 meters per second. How far does he travel? So I have a VI, VF, an acceleration, and I want to know a distance. So the equation that I have to use is VF squared is equal to VI squared plus 2AD. That's for number 2. I'm going to skip the substitution, really showing you guys that. So I'm going to do 21 squared minus 15 squared. Now I'm going to divide that by 2 times 3. I'm getting 36 as my answer. Sure that's right. You're telling us the wrong answers here. Number 2 is choice 3. Good. Okay, so I knew that by what variables they told me, I knew what equation I had to use. 3, a battery-powered electric motor is used to cause the wheels of a toy car to rotate. In this motor, there is a conversion of, so it's battery-powered, so that's electrical energy, and then that is going to be making the wheel rotate, so that's going to be turned into mechanical energy, right? Mechanical means kinetic or potential. So we're taking the battery and making something move. So that's electrical motion into mechanical motion. 4, projectile is launched horizontally from a height of 65 meters. Okay, so it's important you recognize, when is a projectile launched horizontally compared to when is a problem talking about a ground-launched projectile? Here we have a horizontal projectile. Height of 65 meters, an initial speed of 35 meters per second. What is the projectile's horizontal speed after it's fallen 25 meters? Well, remember, the horizontal speed does not change, right? In the horizontal direction, the acceleration is always equal to 0. So the velocity has to be constant. So that means that 35 meters per second does not change. Still 35 meters per second. Question 4 was 2. Good. All right, question 5. Looking at the free body diagram, 10 Newton force and a 10 Newton force, they look like they're balanced. The diagram below represents 2 forces acting concurrently. That just means at the same time on the block. Which statement best describes the motion of the block? The block is not going to be accelerating because the net force is 0. So the acceleration is 0. The block is moving to the right with a constant speed, or the block is moving to the left with a decreasing speed. So choices 1, 2, and 4 are all talking about acceleration. Choice 3 is the only one where we have something in equilibrium. So we know that's got to be our answer. 5 is choice 3. 6, the magnitude of an unbalanced force applied to a 4-kilogram crate is 10 newtons. If the magnitude of the applied unbalanced force is doubled, the inertia of the crate is going to remain unchanged. Inertia just means mass. So the mass of the box doesn't change just because you pushed it harder with a greater force. It's going to accelerate more, but that does not mean that it changes its mass. 6 is number 2. A 60-kilogram man is pushing a 30-kilogram lawnmower. Compared to the magnitude of the force that the lawnmower exerted on the lawnmower by the man, the magnitude of the force by the man on the lawnmower is, so this is just Newton's third law, equal and opposite forces. So it has to be the same. So 7 is choice 3. Okay, 8. Looks like I got a car going around to a circular track. Yep, vertical circle. When the car is at the position shown, what is the direction of the centripetal force acting on the car and the velocity of the car? The centripetal force always points to the center of the circle. And if something's moving in a circle, we have a tangent velocity. So let's see. That's what the directions are. Let's see the answer choices. Force to the right, velocity downward. Choice 1. Okay. Sorry, Google Meet was going off. Okay, so 8 is choice 1. Let me just make sure that's right. Yes, good. Question 9. An electric motor has that much power used to raise something weighing that much at a constant speed. What is the total time required for the motor to raise at a distance of 20 meters? So the equation that I want to use for number 9 is the power is equal to the force times the distance divided by time. So I have my power in watts, I have my force, and I have a distance 20. So I just need to solve for t there by doing the force, 2.8 times 10 to the 4, times the distance, 20, divided by the power, 6.48 times 10 to the 4. Getting 8.75. Did I type something wrong? 6.48 in the denominator. So I was, answer choice was off a little bit, 8.64. There you go. Choice 3. And number 9 is choice 3. 10. A person standing on a sidewalk hears a siren of an ambulance as it approaches, passes by, and goes away from the person. Compared to the frequency emitted by the siren, the frequency observed by the person is, well, first it's approaching, then passes and goes away. So it's going to be a higher pitch, and then it drops down to a lower pitch. So if this is frequency versus time, we have a higher frequency and then a lower frequency when the thing passes us. So approaching is a higher frequency and going away is a lower frequency. So 10 is choice 3. 11, which particles exhibit properties of waves in some experiments? Photons and electrons act as waves and particles, right? That's that wave-particle duality we talked about in modern physics. So question 11 is choice 3. 12, the direction of the electric field at a point in space is defined by the direction of the force exerted on a positive test charge located at that point. That's the definition of electric field, so you should know that definition. 13, a net force of 1 Newton will, so F is equal to ma. So a 1 Newton force causes a 1 kilogram object to accelerate at 1 meter per second squared. So choice 1 is accurate by Newton's second law. The units do work out so that 1 Newton makes 1 kilogram accelerate at 1 meter per second squared. 13 is choice 1. 4, the elongation of a spring will be quadrupled if the magnitude of the force on that spring is also quadrupled, because the force of a spring is equal to k times x. So we have a direct relationship there. And 14 moves 4. 15, vector diagram represents the distances run in a race, the displacement of the student from start to finish. Okay, so remember the displacement is just a vector pointing from start to finish. So this is the value that I'm looking for. And it's not horizontal at all. So actually 0.8, 1, and 1.8 all cancel out. So I just have 0.8 and 0.6, which represents just 1.4 south. And if I add those lengths together, that's equal to the net displacement. So it's just 1.4 south. 15 is choice 2. Nice. Okay. The diagram below shows an arrangement of charges, indicate the forces acting on them. So notice that A and B are attracting, and B and C are attracting, but A and C are repelling. So what spheres have the same sign? So remember that means that they need to repel. Opposites attract, like charges repel. So that's A and C only. $16 is choice 2. Yes. Two small charged spheres located at distance d from each other experience a force F. If the charge of each sphere is tripled, Fe is unchanged. What other change must have occurred? So if the charge on each sphere is tripled, that means that the force is going to increase by a factor of 9. The only other thing we're in control of is the distance. So we need the distance to decrease the force by a factor of 9. But remember, it's r squared in the denominator. So we really only have to increase the distance by a factor of 3. And then that gets squared to get you a factor of change of 1/9, which cancels out the tripling of each charge. So that's an algebraic reasoning question. It's the equation is K Q1 Q2 over r squared. And remember, we would plug the 1s in for everything and get the forces equal to 1. Well, what they're saying is that both of the charges are 3, so you have 3 times 3 up top. What do you have to do to the denominator, to the distance, in order to get that this force to still equal 1? Well, it's 3 squared in the denominator, so tripling the distance. 18, compared to the resistance of an aluminum wire, the resistance of a tungsten wire is approximately what? So it has the same length and the same diameter. The only other thing is the resistivity, because remember, the resistance is equal to the resistivity times the length divided by the area. So for aluminum, it's 2.82 times 10 to the minus 8. And then for tungsten, it's 5.6. So tungsten has times 10 to the minus 8. Tungsten has double the resistivity, so it's going to have double the distance. The tungsten wire is approximately, the resistance of the tungsten wire is approximately twice as great, because the resistivity is twice as great, and there's a direct proportion there. 18 is 2. Good. 19, how much energy is expended when a current of 5 amperes is in a 5 ohm resistor for 5 seconds? Whenever they're asking about energy and they're talking about circuits like amperes, ohms, voltage, we're always going to go to the part of the reference table that's W equals all those different expressions, and you have to pick the right one. So they're giving me current, resistance, and time. So that's I squared RT is the formula that I'm going to use. So the current is 5 squared times 5 ohms times 5 seconds gets me 625. Choice 3. 20. The amount of electrical current through an unknown resistor may be measured by. Okay, so whenever you want to measure the current going through a resistor, remember I would always say, oh, you just put the ammeter right on the wire, right next to the resistor. Another way of saying that is the ammeter needs to be in series with the resistor, so that the current goes through the ammeter, and then the ammeter can actually measure the current that is equivalent to the current going in the resistor. Because if these were in parallel, if I had like a battery over here and a resistor, and I set up an ammeter in parallel, the different branches get different amounts of current. So the current that the ammeter is measuring is not the current that's going through the resistor. So it would have to be in series. So it is choice 1 here, an ammeter in series with the resistor. Check in 20 is choice one. Still recording, right? Okay. What's up?
How's it going?
Good. Making
So I just put together masters for you guys.
All right.
I don't know. One of the first things we do is we basically just write a number on each of the exams, and that way it's just easier to
All right.
make sure you got them all. So there you go.
All right, cool. Thank you.
All right, man. Have a good one.
Yes, you too. Sorry, someone's getting through. All right. 21. Which phenomena represents a wave spreading out behind a barrier as the wave passes by the edge of a barrier? So spreading around a barrier is diffraction. By definition, that's just kind of a memorization question. 21 is 1. 22, 1 kilometer length copper wire with cross-sectional area of that has a resistance of that. Another copper wire, it's the same resistivity. Again, the formula that they're asking about is rho times L over A. Another copper wire, half as long, twice the cross-sectional area. What is the resistance of the copper wire? Okay, so I'm just going to plug in all the proper numbers. So 1.72 times 10 to the minus 8. So that's the resistivity of copper times the length of copper, which they said it was half as long. So actually, instead of plugging into my calculator, here's what I'm going to do. I'm going to think about how, because they gave me the resistance of this original wire. It was 0.712. Now they're telling me the wire's half as long. So that's going to reduce this resistance by a factor of 1/2. And it has twice the cross-sectional area. Well, cross-sectional area is in the denominator. So doubling that divides that number again by a factor of 2. So really the resistance is decreasing by a factor of 4. So 0.172 divided by 4 gets me 0.043. Choice 1. So I could have like figured out how do those values change individually, like the length and the area, and then substitute that in. That would be more work though. So I just thought about the proportions happening in the equation. 23. The magnitude of the electric force exerted on a small positive charge located between two positively charged plates is the same everywhere between the plates, because remember the electric field is constant in between two plates, and the electric field is directly proportional to the force on a charge. So if the field is the same and the charge doesn't change how large it is, the amount of charge, then the force has to stay the same. So 23, verse 4. 24, an acoustic organ is a musical instrument with pipes. The oscillation of air molecules in the pipes of an organ produces sound waves that are mechanical and longitudinal. Again, another fact you just have to know. 24 was 3. Which list identifies portions of the electromagnetic spectrum in increasing frequency? Infrared, visible, ultraviolet, gamma. Goes from smallest to largest, increasing frequency. You have to use the spectrum if you don't have those ranges known. Got to keep checking. 25 is 3. 26. A tuning fork is used to produce a sound wave having a frequency of 512 hertz. What is the wavelength of this sound wave in air at STP? So the velocity is equal to the wavelength times the frequency. It is sound in air at STP goes at 331 meters per second. That's at the front of the reference table. That's equal to the wavelength times 512. So when I divide by 512, it's something a little bit smaller than 1. 0.646. 27. An amplified sound wave produced by an opera singer shatters a glass. Which phenomena best explain this? This is resonance, because the sound waves, the vibrations are going from the singer's voice, from her vocal cords to the glass, and those vibrations are being transmitted at the proper frequency, which causes big vibrations in the glass, and eventually it shatters. So that is resonance by definition. What is the motion of the particle P shown in this wave? What in the next moment in time? What is it doing? So the wave is traveling to the right. So this peak is traveling to the right, and this is a transverse wave. So point P is not going to move left or right. So we need to decide, is it going to move up or down? P is not moving to the right. It's the wave that moves to the right. So pretty soon there's going to be a peak happening at point P, right? This thing is just going to move to the right. And when that happens, point P has to go up in elevation in order to remain on the wave. And then as the wave continues, pretty soon this piece of the wave will be at P, and it will have to go downward after that. But right now, what's happening to the left of point P is the wave is above it. So point P has to go upward in order to remain on the wave there. 28 is 4. If several resistors are connected in series in an electrical current, the potential difference across each resistor. So if you have, let's say you have a 9-volt battery, and then you have 2 resistors in series, and they're 1 ohm each. Then they each get 4.5 volts. They get equal volts. But if one of the resistors were to increase in resistance, let's call this one 2 ohms, the battery needs to use more energy to get the current to go through the 2 ohm resistor compared to get the current to go through the 1 ohm resistor. So actually you get more voltage the bigger your resistance is in series. So it actually varies directly with the resistance of each resistor. That's a pretty tough question. 29 is 1. You could, like, if you didn't know that answer, you could, like how I picked numbers, 9-volt battery. What if both of the resistors are 1? What are each of the voltages? Well, what if one of the resistors has 2 ohms? What voltage does that one get? And just by doing that short example, you can make a VIR chart. You could figure that out. I mean, that's basically what I did in my head there. 30. In medium X, light travels that far at that fast. In medium Y, light travels with that wavelength. What is the speed of the light? Okay, so then they want me to use this V1 over V2 is equal to lambda 1 over lambda 2. So in X, I'll call that medium 1. So this is lambda 1, and this is V1. And I'm solving for V2. All right. Skipping some algebra steps. That's what you have to substitute in. So V1 times lambda 2 divided by lambda 1. It's me something really close to 2 times 10 to the 8. And choice 30 is 1. Did it. 31, a nuclear reactor produces that much energy per year. How much mass is converted per year? E equals mc squared. So I'm just going to take that energy and divide it by the speed of light squared. So 2.7 times 10 to the 16 divided by 3 times 10 to the 8 squared. 3 to the 30. I did put a -8 by accident in the exponent. There we go. It's just 0.3 kilograms. 31 is choice 1. Spheres are brought into contact and separated, the net charge in B, you have to take the average of the charges. So you're taking the average of these two numbers. -7 times 10 to the -6 plus 3 times 10 to the -6 is -4 times 10 to the -6. Divide that by 2 because I'm taking the average, and I get -2 times 10 to the -6. And 32 is choice 2. 33. An anti-muon neutrino is a lepton, and it's a neutrino, so it's neutral. 33 is 2. Oh, superposition. The superposition of the waves will cause the particle in the medium to have a maximum displacement of what? Okay, so these waves are in phase, right? Notice how the peaks are lining up with peaks and troughs line up with troughs. So you just add their amplitudes together because constructive interference is happening here. So 3 meters tall and 2 meters tall, 2 and 3, add up to 5. Just add the amplitudes together. So that was number 34 is choice 4. 35. Ooh. A wire moving through a magnetic field. Moving the wire downward between the poles in the direction shown in the diagram will induce a potential difference in the ends of the wire, and it'll cause a current to flow. We didn't really focus a lot on the fact that when you have a wire moving in a magnetic field, you do get electric current flowing in that wire. That is a fact that does happen. So there's no math associated with that. You just need to know that when there's a magnetic field and you are moving a wire through that field, you will end up getting current flowing through the wire. So that was 35 is choice 2. 36. Okay, so now I'm on part B1. Okay. 36. Which graph best represents the motion of an object traveling with a constant positive velocity? So because these are displacement graphs, I need a constant positive slope. Choice 1. A cannonball is fired at 100 meters a second at 15 degrees above. What is the horizontal and vertical components? So this is just a trigonometry question. Vx is v cosine theta. And Vy is V sine theta. Those formulas are in your reference table. They're written as Ax is equal to A cosine theta, and A is any vector quantity. So here it's velocity is the vector quantity. And just remember, it makes a right triangle. So we did this a lot in the beginning of the year. I know that we haven't really talked about vectors recently, like in the last units, well, like circuits, waves, and modern physics. You don't really talk about vectors, but remember we spent a lot of time talking about components and motion in 2 dimensions. So 37 is choice 1 if you put that in your calculator. Make sure you're in degree mode. 38, a 1,200 kilogram car is moving at 10 meters per second with a braking force of 3,000 newtons is applied. How much time would it take the car to come to rest? So here, actually, you want to use force times time is equal to the change in momentum. You could do this by figuring out an acceleration. and then figuring out how much time it would take to stop, but you end up doing the same exact math. So 3,000 T is equal to 12,000 times 10. So 4 seconds. Wrong. 4 seconds. 38, choice 4. 39, which graph best represents the relationship between the speed of light in a transparent medium and the index of refraction? It's an inverse relationship. This is what's in the reference table. The index of refraction is equal to the speed of light divided by, in a vacuum, divided by the speed of light in that material. So there's an inverse relationship between N and V. Student uses a string to whirl a 0.25 kilogram mass on a horizontal circular path that has a 0.8 meter radius. If the magnitude of the centripetal force exerted on the mass is 25, what's the speed? So we want to use F is equal to mv squared over r. So I'm solving for the speed. So I'm going to do the force times the radius divided by the mass, and I need to take the square root of that, and I get 8.9. And 40 is choice 2. Okay, they're giving us universal mass units here, and they want to know how many MEVs that would be. On the front of the reference table, it tells us one universal mass unit is 931 mega electron volts. So what if I have 2.39 times 10 to the minus 3 universal mass units? How many mega electron volts does that get me? So you actually just take the number they gave you, 2.39 times 10 to the minus 3, and multiply that by 931 mega electron volts to get 2.22. 41 is choice 2. 42, gravitational force of magnitude F exists between the Earth and the satellite Earth surface. The satellite is sent into orbit at a distance of 3 Earth radii above the Earth's surface as shown. What's the magnitude of the gravitational force between the Earth and the satellite when the satellite is in orbit? Okay, so we need to remember that the force of gravity is G M M over R squared. So I'm taking the radius and turning that into 4 times its value, 4r. So because r is squared in the denominator, the force ends up being reduced by a factor of 16. So 42 is choice 1. 43, as part of an investigation on quantization, a student measured and recorded the mass of 5 identical containers, each holding a different number of pennies. The pennies shown in the student's data. Based on the data, what's most likely the mass of a penny? Well, we need to look for the smallest difference here. So I mean, between these two containers, 35.2 and 38.4, that's a difference of 3.2. So like all these numbers are divisible by 3.2, so that could be the weight of a penny. And what this question is really kind of asking about is the idea of quantization. The idea that in this example, you can't have half a penny. So similar to how we would always talk about, oh, you're not allowed to have half of an electron. What's the smallest amount of charge that you could have? This question is hinting at that idea that there's an amount of mass that equates to 1 penny, and you can't have a fraction of that. You can only have a whole penny. So, and then again, the difference between these two layers, container 4 and container 5, is again 3.2. So because there's no other difference smaller than that between the trials, that is likely the weight of 1 penny, and those containers just differ by 1 penny. It's a weird question. Doesn't really fit in with all the other questions they ask about quantization of charge, but it's a creative question. I'll give them that. Which graph best represents the relationship between the frequency and period of a wave? They are inversely related, right? We have a formula for that. Frequency is equal to 1 over the period. So that's choice 4. And 43 was 1. Good. 45, the current passes that many electrons. Okay, so I is equal to delta Q over T. But they're giving us this in electrons. So I need to multiply that by 1.6 times 10 to the negative 19 coulombs per 1 elementary charge. So I'm really going to do 1.6 times 10 to the negative 19 times 3.15 times 10 to the 18 divided by that time of 10 seconds to get 0.05. And 45 is choice 1. Particle of charge 3 nanocoulombs displace an electric field of that many newtons per coulomb. What's the force? The electric field is equal to the force divided by the charge. So the electric field is 1500. That has to equal to, I'm solving for the force, 3 nanocoulombs. So that's 3 times 10 to the minus 9. 1500 times 3 times 10 to the minus 9. 4.5 times 10 to the minus 6. 46 is charge 1. 46 is choice 1. Okay. 47. Which quantity is represented by the slope of this graph? Velocity, time. The slope tells me about acceleration. Oh. The diagram represents 2 horizontal platforms, different heights, rolls, and goes to the other. What's the total time the ball's in the air? Well, we just need to figure out how long it's going to take the ball to fall. 2.4 meters. The way you do that is by doing, and we're on Earth, because they didn't specify a different planet. D is equal to VIT plus 1/2 AT squared. The distance is 2.4 meters. It's starting from rest because we're only looking at the vertical direction here. And in the vertical direction, the initial velocity is 0. The acceleration is 9.81. I'm looking for the time, and I know the distance was 2.4. 1/2 9.81 t squared, and I'll solve for it. So I'm going to do 2.4 times 2 divided by 9.81 and take the square root of that answer to get about 0.7. 48 is choice 3. 49, 4 mechanical waves are created in the same medium over the same time interval. Which wave transfers the greatest amount of energy? So because they all have the same wavelength. So energy is just related to amplitude. So I just want the greatest amplitude, which is choice 2. Ooh, which diagram represents a light wave increasing in speed? So if the speed goes up, it's because the index is going down, which means the angle is going to go increasing. So I need something going, it doesn't matter if it's going from A to B or B to A, but what matters is the angle of refraction needs to get bigger. So that's not happening in choice 1. That's not happening in choice 2. That is happening in choice 3. Look how big that angle is in medium B. And then medium Choice 4 is just the same thing. So that would have no difference. So it is choice 3 there. Okay, so that is the multiple choice section. I want to do the part 2s, but I don't want to come across one where I won't be able to do it. Let me just make sure. Not be able to do it by not having a ruler is what I mean. Yeah, I think I could do all these. I have a protractor. All right, I could do these. All right, let's get to it. To charge a cell phone battery of that many coulombs of charge is moved through a potential difference of that one, can calculate the maximum amount of energy. So remember, you got to be showing all your work with the equation, substitution with units. So I'll be doing all that. The voltage is equal to the work divided by the charge. So the potential difference was 3.7 volts. That has to equal a certain amount of electrical energy when we had that many coulombs, 3.69 times 10 to the third coulombs. So now I'm going to solve for W by just doing the multiplication of those numbers. .7 times 3.69 times 10 to the third. Gets me about 13,000. Joules. Okay, so that's full credit there. Okay. 55 kilogram ice skater traveling with a force of friction. That's 11 newtons. To determine the magnitude of the weight of the ice skater. This is only 1 point, so I don't have to show my work. So I just have to take their mass, 55, and multiply it by little g, 9.81, to get, I'm going to round, 540 newtons. 54, 55, determine the coefficient of friction between the skater and the ice. So the force of friction is equal to mu times the normal force, and the normal force is equal to the weight here. So I need to do 11 newtons is equal to mu times 540 newtons. So it's 11 divided by 540, which is 0.2. I'm sorry, 0.02. No units there, so. Okay. 56, 57. Student is producing a wave in a flexible spring. Determine the amplitude of the wave in the spring. Well, this whole thing is 1 meter. The amplitude is just half of that, so that's 0.5 meters, right? Good. Determine the wavelength of the wave produced in the spring. So this is 1, 2, 3 full waves in 4.5 meters. So that means that one wavelength is 1.5 meters. I just did 4.5 divided by 3. Okay. A 100 Newton box is pulled up a 20-meter incline by a constant force of 80 newtons. The vertical height gained by the box is 10. Determine the total work done in joules by the 80 Newton force in pulling it to the top of the incline. Work is force times distance. So it is an 80 Newton force times 20 meters, because that was the force that was pushing over that distance. So you get 1,600 joules. And again, 1 point, so I don't have to show the work. Determine the total amount of gravitational potential energy in joules gained by the box as it is pulled to the top of the incline, mgh. So that's just 100 is mg, because that's the weight, times h, which is 10. So you just actually get 1,000 joules. Explain why there is a difference between the total work done by the 80 Newton force in pulling the box to the top of the incline and the amount of gravitational potential energy gained by the box as it's pulled up the incline. They didn't tell us whether the box was speeding up or not. Like, it didn't say constant speed. So I think you could say kinetic energy here, but what I would say was work was lost to internal energy of the system due to friction between box and see. Allow 1 credit for the following responses, but not limited to. The work is converted into other forms of energy, like thermal or kinetic. Friction causes internal energy to increase, so not all of the work becomes gravitational potential energy. If you just wrote friction, that's okay. So they were looking for something about friction and internal energy. But you could have said kinetic energy, that's also valid. All right. We have a 110 ohm resistor, a 220 ohm resistor connected to a potential difference, and we are in parallel. You could tell because there's a junction, 2 different branches for the current. Calculate the equivalent resistance of the circuit. So I have to use 2 points, so I got to show all my work. 1 over Req is equal to 1 over R1 plus 1 over R2. So 1 over Req is equal to 1 over 110 ohms plus 1 over 220 ohms. So what I do is I'm just going to plug into my calculator 1 divided by 110 plus 1 divided by 220, enter, and then do 1 divided by my last answer in my calculator to get a value. So the resistance is 73. 73.33333 repeating. So I'm just going to write 73. Calculate the total current in the circuit. So I would just use Ohm's law. R is equal to V over I. So you have to use the equivalent resistance because they want the total current. So it's the current through the battery. So I have to use the equivalent resistance, not just one of those. 73 ohms is equal to 6 volts divided by I. So when I solve for I, that the current has to be 6 divided by 73, which is really small, 0.08 amps. Yes. 65. Compare the power dissipated by the 110 ohm resistor compared to the power dissipated by the 220 ohm resistor. Power is equal to voltage squared divided by resistance. So because they're in parallel, they get the same voltage. So the larger resistance, the 220 ohm resistor, uses less power. The one with the smaller resistance, the 110 ohm resistor, is more powerful. And again, that's because of power and resistance being inversely proportional. Cool. All right. A group of students constructs a catapult. Student measures 0.8 seconds from the time the ball is released until it strikes the target, 2 meters away. 0.78 is maximum height. Calculate the horizontal component of the ball's velocity. Well, it went 2 meters in 0.8 seconds, so I could just say D is equal to VIT plus 1/2 AT squared. 2 meters is equal to VI. T was 0.8 seconds. 1/2 0 meters per second squared times 0.8 seconds squared. So if I solve for VI, really just 2 divided by 0.8 to get 2.5. Calculate the vertical component of the ball's velocity. I'm going to say VF is equal to VI plus AT. So the ball got to a maximum, right. The ball got to a maximum height. So at maximum height, the velocity was 0. So that's the final velocity I'm working with in this question. I'm looking for the initial vertical velocity. So that's VI plus, I'm going to put minus 9.81. So I got a positive velocity out of this. The time was 0.8 to get from here all the way to the target. So it only took 0.4 seconds to get to maximum height. So that means that that initial velocity was really 3.9 meters per second. Check those. 2.5 and 3.9. Good. 70. On the diagram in your iceberg, draw an arrow originating at point P that represents the ball's direction of acceleration. It's straight down because gravity points straight down. So it has to be straight down. You have to include that arrow. All right, 71. A spring of that spring constant is compressed 0.1, a 3 kilogram block. The block then collides with a 1 kilogram block, and they remain joined. Okay. Determine the total amount of elastic potential energy stored in the spring when it's compressed 0.1 meters. 1/2 kx squared. So you end up substituting, what was that? 1/2 times 2,600 times 0.1 squared, and you end up getting 13 joules. Don't have to show any work for that one. Assuming all of the spring's energy is transferred to the 3 kilogram block, calculate the speed after it's, okay, so the kinetic energy. If there was 13 joules stored in the spring, the kinetic energy is 1/2 mv squared. So 13 joules of kinetic energy is equal to 1/2 mass of 3 kilograms v squared. So when I'm solving for v, 13 times 2 divided by 3, and take the square root of that answer to get 2.9. Cool. 74, 75, calculate the speed of the blocks after the collision. Pi equals Pf, the momentum before equals the momentum after. So the momentum before is just the 3 kilogram block going at 2.9 meters per second. And then after the collision, they stick together. So it's 4 kilograms total times. Oh,
This is actually the alphabetized one.
all right, cool.
So I don't know, you want to keep both?
Yeah, why not? Thank you. 4 kilograms for the total mass times v, the velocity I'm looking for. So I'll do 3 times 2.9 divided by 4 to get 2.17. 5 meters per second. Cool. All right, 76. Mercury atom emits a photon as it goes from. Oh, is this? I think this is on our test. Let's see. Determine the energy in electron volts. So level F is 2.68 minus level D, which is 4.95.
All right, we'll do.
I'm getting 2.27 electron volts. Then determine that in joules. So I have to do 2.27 times 1.6 times 10 to the negative 19 to go from electron volts to joules. (3.6 times 10 to the negative 19 joules. Calculate the frequency of the emitted photon. E is equal to HF. The energy I just calculated has to be plugged in joules. 3.6 times 10 to the negative 19 joules has to equal Planck's constant, 6.63 times 10 to the minus 34 joules times a second. If you didn't write that, you could lose half the credit for this problem. Times F. So when I solve for F, plug it in my calculator wrong. There we go. 5.48 times 10 to the 14th power. Unit is hertz. That is green light. Yep, it's green. All right, use a protractor to determine the angle of incidence at point O. So I need this angle. My protractor. Line up my vertex. And remember, you got to hold it so that 0 degrees corresponds with the normal. So that looks like 28. All right. It is 28 plus or minus 2 degrees. Cool. Calculate the angle of refraction as the light ray leaves the fused quartz and goes into air. So I have to use Snell's law. Fused quartz, 1.46. Sine of 28 degrees has to equal 1 sine theta. And theta is, so I'm just going to do 1.46 times the sine of 28. I was in radian mode. Good thing I checked. Got to be in degree mode. So I got 0.685, and I have to take the inverse sine of that to get theta as 43 degrees. Then I need to draw that. So over here, I need to flip my protractor around. Make a little mark at 43. And then you'd use a straight edge, I'll use the line tool. Do it in red. Perfect. I'll even label my angle. 43. that what I drew? Yeah, 43. Cool. That compare the frequency. It's the same. It never changes. All right. So thanks for watching. See ya.